Okay. Um, I'd like to gather a bunch of different water pollution topics. And some of these we're going to come back to later, but some we're going to talk about today. So, organic material is, things that decompose. So, like feathers and cat poop from urban runoff, or animal blood from feedlots, or like wood shavings from the logging industry, or plant material from agriculture. These are examples of organic material. And I have a huge lecture about this coming on Monday, so I'll leave that for Monday. And I made a typo here. Another type of pollution that we often see in rivers is excess nutrients. The agricultural ones, if you ever see NPK, just think farming. If they say like nitrogen, phosphorus, or potassium, you're like, oh, NPK, something to do with farming. Excess nutrients are a really big problem with agricultural runoff, also from urban runoff. And again, I will have a big lecture on this. I made a typo. This screen says more on Monday. It should have said more on Tuesday. So 25, 26, 27, we're going to come back to later. But since we've been talking about rivers, I want to discuss some other types of pollution that you're likely to see when we impact rivers. I told you this sort of assembles information about rivers and creeks. So I want to talk about the last three now. Anytime you hear coliform bacteria, there's like, you don't need any lecture. It's just poop. Like, it's not healthy to eat because it causes bacterial warfare in your digestive system. So untreated sewage can make you really sick. Urban runoff can make you really sick because a lot of poop ends up in our landscape. Dirtbags like me that pee outside, not such a big deal. But if it was a real emergency, somebody might have pooped outside, and that is a big deal. We also have a lot of pets. So urban runoff has a lot of untreated sewage. There are also cities which have no sewage treatment at all. So that's a really serious type of urban runoff. You get a lot of coliform bacteria from feedlots, and remember, your intestines are anaerobic. So if the environment looks like an intestine, intestinal bacteria will thrive. Anytime that you see coliform bacteria, you should think poop. That's unhealthy. And remember that these really thrive in anaerobic conditions when there's no oxygen around. Whenever they close the beaches after a storm, that's because a bunch of canal water dumped out into the ocean, and there's a short-term bacterial warfare happening that you don't want to go play in. If you've ever heard of beaches being closed because of unhealthy conditions, this happens a lot in Arroyo Burro. That's because Arroyo Burro has a really shallow canal right in front of the beach, and it accumulates stuff, and it gets anaerobic because the water's pretty stagnant, and all of the runoff from Ealing's Park and those communities right there near Arroyo Burro, all that poop builds up, and you've basically got like an intestinal party happening in the canal by Arroyo Burro. And then when it dumps out into the ocean, the first storms of the year, they usually close that water because there's intestinal bacteria warfare happening. Study goal number 30 is about sediment. And rather than coming back to number 30 later, I'd like to just do that one now too. Sediment has 5 primary sources. You should know these. And they're roughly equal globally. So about 20% logging, about 20% agriculture, about 20% mining, about 20% construction, and about 20% dirt roads. roughly equal. Those are the 5 sources of sediment pollution. And it turns out that sediment is the #1 water pollutant worldwide. We talk a lot about plastic and stuff, but the amount of sediment in water is way greater. And you should get ready to write. I didn't have space on this slide. But we call sediment pollution a double problem. So get ready to write. One problem, of course, is that you've lost sediment somewhere. So that used to be topsoil. One problem is that it's gone. So that's what we call erosion, when you lose the material from the ground. The other problem is when all of that eroded stuff goes to the wrong place. I've got a list for you of all of the reasons why this is such a severe water pollutant. Okay. #1, sediment can clog canals. And so for flood control, like near cities, sediment can accumulate and that can stop them from doing their canal thing. #2, sediment pollution can overwhelm ecosystems and bury vegetation. Maybe you've seen this in a river somewhere where there's a whole bunch of dirt that covered up plants all of a sudden. #3, sediment pollution makes water hotter, right? Because the water's now darker. It's gone from clear to like dark brown. #4, sediment pollution can block sunlight. And #5, there's a lot of things that lay their eggs in between rocks. It's a good place for eggs to settle. So like salmon lay their eggs in coarse gravel, and those salmon eggs get fed by circulating water. Those are called egg beds, like bed. And so sediment pollution can bury egg beds. Kind of surprising that sediment is such a big whoop, because it's a bummer when you don't have it. Sediment is needed in some ecosystems, and you can have too much of it. Those 5 activities create sediment pollution. It's tricky. This is one of those things where you can have not enough, or you can have too much, or you can have it in the wrong place. Sediment. Finally, for #31, there's a problem that we associate with mining, like the name says, called acid mine drainage. And this will come back later, but here's like a truism of environmental science. Oxides plus water equals acids. So like carbon dioxide plus water makes carbonic acid. Sulfur oxides plus water makes sulfuric acids. Nitrogen oxides like NO2 or NO3 plus water make acids. An oxide is something stuck with oxygen. So oxides plus water make acids. You have to know that. And think about what a mine is. It's a place where you dig things up, right? And whatever you dug up has been in the ground for a long time, right? So like, if this had been buried, then this hasn't seen oxygen for a long, long time. Anything that you dig up, because it was underground, when it comes to the surface, will interact with the air, and it'll make some oxygen bonds. That's called oxidizing. So, you know, if you like take a block of iron and you leave it out in the elements, it will oxidize, it'll rust. Oxidizing is mixing with oxygen. And because mining is bringing stuff out from the ground, then that stuff is going to interact with oxygen. It's going to oxidize. So whenever you have a mine, you've got a bunch of stuff that's like, coming out into the light and starting to interact with oxygen. That means you've got the oxides, and it rains sometimes. So freshly dug up stuff gives you the oxides, rain gives you the water. And so mines create acidic runoff. Mines have all the ingredients to form acid. It's called acid mine drainage. It's a natural consequence of mining. And making water acidic can really affect wildlife. Sometimes the acidity levels that you get downhill of mines are extremely acidic. Some of the lowest pH ever measured on Earth was downhill of a mine in Oklahoma. So this slide here was supposed to help you connect pollution sources with the pollution type. This is a really common College Board question. They'll say, if you're testing water, what could have caused this organic material you see, or this excess nitrogen level you see, or what would have caused the coliform bacteria or the low pH. So this is a really useful slide. I hope you photograph it and save it for later. I hope you'll ask me questions if my explanation sucked. I'm starting to get really sleepy, so I'll see you guys later.